Here's the solutions video to your radical equation homework. Alright, let's see. We had to solve and we had to check for extraneous roots. We always check for extraneous roots. Alright, number one is easy because the radical is already by itself, so let's square both sides. So the square of the square root of x is just x, and I get 10. 100. Whew, 100. X is equal to 100. Easy peasy. Let's do a check because we have to check, and we always check in the original. The square root of 100 is in fact 10, so 10 equals 10, and I am done. Moving on to number 2. The radical is already isolated, so we can just go ahead and square both sides. On the left, you're going to be left with a minus 4. When you square a square root, they cancel out. 3 squared is 9. Add 4 to both sides, so I get a is equal to 13. And now let's go ahead and check. We always check in the original. So this is the square root of 13 minus 4 is equal to 3. This is going to be the square root of 9. And that is in fact 3. Whew. Scrolling down. Alright, number 3. The radical is not by itself. You could do this 2 ways. You could subtract the 4 and divide by a negative. That's fine. I'm going to avoid doing that. I'm going to add the square root of x to both sides and subtract 7. Alright, when I add the square root of x to both sides, that moves over here. Subtract 7 from both sides. 4 minus 7 is negative 3. So now let's go ahead and square both sides. And here, negative 3 squared is positive 9 equals x. So there's my answer. Now let's check. Checking the original. So I get 4 minus the square root of 9 is equal to 7. So here I get 4 minus the square root of 9 is 3. I get 1 is equal to 7. That is not true. So you need to reject this solution because it is an extraneous root. Sorry about that. My phone went off. Alright, now number 4. Again, it is already good because the radical is by itself. So let's go ahead and square both sides. On the left, this a squared is just a squared. And then this is equal to a plus 6. Well, here we have a quadratic. We always like to solve quadratics by getting them set equal to 0. And then we could use the quadratic formula or completing the square, but this factors into a minus 3 and a plus 2. Zero product property says that these break up. So I get a is equal to 3 or a is equal to negative 2. So now we have to do 2 checks. Alright, let me extend my page. We got to do 2 checks. And if this didn't fit on your paper, you can go on the back or you can do it on separate paper. I don't care. And we check in the original. So when I check 3, this is going to be 3 is equal to the square root of 3 plus 6. So 3 is equal to the square root of 9, and that checks. When I check negative 2, I get negative 2 is equal to the square root of negative 2 plus 6. So I get negative 2 is equal to the square root of 4. And remember, I only care about the positive square root for these questions, so this does not work. We're going to reject this. Oops, we don't reject there, we reject here. We put a sad face here. Alright, so a equals negative 2 is an extraneous root. On to the next. We already have the radical isolated, so let's square both sides. I get x plus 9 is equal to 1, because 1 squared is 1. Subtract, I get x is equal to negative 8. Now I can check. We check in the original. So I get that the square root of negative 8 plus 9 is equal to 1. That's the square root of 1. 1 equals 1. everything is bueno. Moving over to number 7, I gotta add 1 to both sides, so I get that 8 is equal to the square root of a plus 3. Now that the radical is isolated, you can square both sides. So I get 64 is equal to a plus 3. Subtract 3 from both sides, 61 is equal to a. And now let's check in the original. So 7 is equal to the square root of 61 plus 3 minus 1. That's really the square root of 64. And the square root of 64 is just 8. So you get that 7 equals 7. Woohoo! Scrolling down. All right, hopefully nobody freaked out about this. Okay, to get the radical by itself, right now we have a radical times 3, so we're just going to divide both sides by 3. So I get 10 is equal to the square root of 25w. And now I can just square both sides. So I get 100 is equal to 25w. Divide both sides by 25. You get that w is equal to 4. I can check in the original, so 30 is equal to 3 times the square root of 25 times 4. 30 is equal to 3 times the square root of 100. So 30 is equal to 3 times 10, and 30 is equal to 30. Woohoo! On to number 8. Let's subtract 10 from both sides, so I get that the square root of 10x minus 1 is equal to 3. Now I can square, so I get 10x minus 1 is equal to 9. Solving for x, so add 1 to both sides, 10x is equal to 10. Divide, you get x is equal to 1. Now let's check. Let me get some more space. There we go. We check in the original, so I get 10 plus the square root of 10 times 1 minus 1 equals 13. That's just, well, 10 times 1 is just 10. And that becomes the square root of 9. And the square root of 9 is 3. So I get 13 equals 13. Woohoo! Is that it? Awesome. On to the last. Woo! Gotta subtract 4 from both sides to isolate the radicals. This is the square root of x minus 2 is equal to x minus 4. Now here we gotta be careful when you square the right side. Okay, remember x minus 4 squared means I'm doing x minus 4 times x minus 4. You need to FOIL. You are not going to get x squared minus 16. Alright, over here I get x minus 2, and then this is going to be x squared minus 8x plus 16. It's a quadratic. Let's get it equal to 0. I'm going to get x squared minus 9x plus 18. And this is going to factor into x minus 6 and x minus 3. Zero product property means that x minus 6 equals 0 or x minus 3 equals 0. So I get x equals 6 or x equals 3. We need to check, and we need to check in the original. I'll check 6 first. So this is going to be 6 minus 2. I made that way too big. Woo. 6 minus 2 under the radical plus 4 is equal to 6. So this is the square root of 4 plus 4 equals 6. 2 plus 4, I am losing my mind today. 6, there we go. And I get 6 equals 6, woohoo! And then I gotta check 3, right? So now I've got the square root of 3 minus 2 plus 4 equals 3. This is the square root of 1. Which I'm getting 1 plus 4 equals 3, and I don't know about you, but 5 definitely does not equal 3. So we have to reject x equals 3 because it is an extraneous root. All right, dos más, I think. No! All right. Radicals are already isolated, so let's square. Here I'm going to get 3a minus 5. All right, on the right, you have to FOIL. This is really a minus 5 times a minus 5. So that is going to give me a squared minus 10a plus 25. Just like before, let's get this equal to 0. So that's going to be a squared minus 13a plus 30, which is going to factor into a minus 10, a minus 3. Use the zero product property, a minus 10 equals 0, or a minus 3 equals 0. So I get a equals 10, or a equals 3. I will do my check right below. Remember, checking the original, I'll check 10 first. So this is the square root of 3 times 10 minus 5. And let's see, that's equal to 10 minus 5. What's over here? That's going to be 30 minus 5. Here that's 5. This is going to be the square root of 25. And boom baby, I get 5 equals 5. Now let's check 3. I can see if I can fit this in here. So I'm going to get 3 times 3 minus 5 is equal to 3 minus 5. This is the square root of 9 minus 5, and here I get negative 2. That's the square root of 4. Remember, I only want the positive square root, so this does not check, and we need to reject, because that is an extraneous root. Almost done. For number 11, again, we have to square both sides. So here I'm going to get 1 minus 2x. Over here, this is going to be 1 plus x times 1 plus x. Don't freak out because the x's are second. You still FOIL it. And you are going to get 1 plus 2x plus x squared. Now I'm going to get this equal to 0, and I'm going to kind of put it in standardish form so the square is in front. So this is going to be 0 is equal to x squared. You add 2x to both sides, so that's plus 4x. And subtract 1 from both sides, and so those ones go away. Remember, we always look for a GCF first. And here we do have a GCF of x, and we are left with x plus 4. So still by the zero product property, that means that x is equal to 0, or x plus 4 equals 0. So I get x equals 0, or x equals negative 4. And these are the two things that I'm going to check. And I'm going to fit it right in this purple box. So let's see, this is going to be the square root of 1 minus 2 times 0, which is equal to 1 plus 0. This is the square root of 1 equals 1, and you get that 1 equals 1. Whoop, that was easy. When I do negative 4, that's going to be the square root of 1 minus 2 times negative 4, which is equal to 1 plus negative 4. This is the square root of 1 plus 8. Negative times a negative is positive. Here I get negative 3. That's the square root of 9. And just like before, I only care about the positive square root. So this means I get 3 is equal to negative 3, which is not true. So we are going to have to reject this as an extraneous root. And, all right, a lot of people were struggling with this today. Kind of bummed me out because I thought it wasn't too difficult, but that's okay. All right, remember, we can rewrite radical expressions using fractional exponents. All right, we talked about this the other day. Remember, I talked about knocking over the fractional exponent, or I told you that story about the whole bottom and the crack thing. So, either way, for part A, this is equivalent to x to the 3/4 power. Okay? If you think about it, the bottom of your fraction, the denominator, that's right here. That's what goes in the crack of the radical. That's your index. Or you can think of if you took that fractional exponent and you knocked it over, the 4 stays on the outside, the 3 goes on the inside. For part B, I've got this a to the 4th on the outside, and then on the inside, I've got the radical, so that's what's going to get the fractional exponent. So this a to the 4th is going to stay, and then this b to the 7th c, since this is the cube root, this is the same thing as the 1/3 power. All right, but we can also write this as a to the 4th, b to the 7/3, c to the 1/3. Okay, you can kind of break it up like that. So if I had knocked the b's over separate from the c's, either of those are correct. For c, here everything's under the cube root. Everything's under the radical. So this is the same thing as 5x squared to the 1/3, which would be the same thing as if you wrote 5 to the 1/3 and then x to the 2/3. Okay, either of those are correct. And then for d, we have the square root of 1 over x. So when we do this, this is really 1 over x to the 1/2 power. And that is that, all right? Remember, if you don't have an index explicitly written, we assume that it is A2. And boom, baby, I am done. Make sure this is corrected completely because I will be checking it for a grade next class.